Hello YouTube fam. Welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In this video, we will use instance segmentation to segment different types and instances of fruit. For more details about Roboflow and Ultralytics, please refer earlier videos. We thank them for the awesome technology and code samples. Let us first see what is semantic segmentation. Semantic segmentation involves dividing an image into regions based on category, but does not differentiate between different instances of the same category. Every pixel is labeled with a class, but individual objects are not uniquely identified. Let us now understand what instance segmentation is. Instance segmentation identifies each individual object in an image and delineates its boundaries. This means that each object of the same category is distinctly segmented with a unique identifier. In more advanced versions of YOLO, capabilities have been extended beyond bounding box predictions to include segmentation masks, which can be used for instance segmentation. This involves not only locating objects within an image, but also segmenting each instance of the objects. This method is more detailed than semantic segmentation, as it provides not only the class label, but also distinguishes between different objects of the same class. Here are the steps for implementing the code. You can refer attached Jupyter Notebook for more details. The YOLO fine-tuning training works well on GPU, and this was done on Google Colab with T4 GPU. Step 1. Generate video with different fruits. Step 2. Convert video frames to JPEG images. Step 3. Use Roboflow to upload and annotate the images. Draw polygons using Smart Polygon Tool and Freeform Polygon Tool. Label each fruit. Step 4. Download the annotated dataset. Perform YOLO fine-tuning training using this custom dataset. We will start with YOLO V8M Seg pre-trained model. Step 5. Run prediction to view segmentation and masks. Let us now see a demo of the fruit segmentation using computer vision. As we can see from the inference results, we can see the model identifies different fruits like banana, plum, lemon, orange, and so on. Okay, we can see bounding boxes around each fruit. Good. We can see the segmentation masks overlaid on each fruit. We also see the confidence level. All right, we will also use a test image with multiple bananas, which we did not use for training. Here we can see model has identified different instances of bananas. It has created 3 different bounding boxes and different segmentation masks to identify each banana individually. Now to make the displays interesting, we will see the original image with bounding boxes. We will also display image with masks side by side. It looks cool. That is it, folks. We discussed how to fine-tune a YOLO model and perform fruit segmentation using computer vision. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning and algorithms. If you found this video helpful, don't forget to hit that like button. Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.